start, sir.
A very good afternoon to all of you. Welcome to the live session 2 of the course Introduction to Automata and Language and Computations. So my name is Sourav Mukhopadhyay. I am your instructor. This is now we are running the 11th week has just started. So we have completed 10 weeks of this course, and I hope all of you are enjoying the course and doing the assignment on time and submitting it. And today I just recap just give a bit summary of the course. And if you have any questions, then we can just questions or suggestions or queries, then we can just concentrate on that. Okay, so so far what we have done, we have started with the finite automata, DFA, deterministic finite automata. It's a 5-tuple. We have a finite set of states where our machine can move from one state to another state with the transition rule. So we have another delta, which is a transition rule, which is input is a state and another is a symbol, which change from one state to another state with this along with the Dept symbol. We call that is the alphabets. So we have a set of alphabets. So then we define we have a starting state and then we have a final state. Then we define how we can extend this delta to delta hat, so that we can eventually we have to accept some string. String is a collection of alphabets. So then we extend this delta to delta hat with the starting state. We can if we can reach to a final state at the end of the string reading. Suppose it's written in the table, we are just reading sequentially one by one, and each step we are at some state, and with that input, another input as a step symbol, that will be decided by the transition rule where we will go. So we'll go to another state, or maybe in the same state. So depending on the transition rule, what we have. So so that way we just define the set of the language accepted by the DFA, which is basically the set of string by which we can reach to the final state, starting with the starting state after ending the string. So then we move to the non-deterministic move, like NFA. So like there we have not a deterministic move. We have many options to go from one state with one input. We can input type symbol. We can go to many other states. So it's the output will be, earlier output was a single state, but here it is a subset of state. So that way it is non-deterministic. So we have an option. So we have an option to choose the path. So then in that case, how we can define whether the string is accepted or not. So we have different path, because it's a non-deterministic. From one state with one input, we can go to say many different states. So like this, we go and move. We can extend the delta to delta hat, and then if one of the path can reach to the final state, then we say this string is accepted. So this string belongs to the language accepted by this NFA. So then we have seen the equivalence of this NFA and DFA. Basically, we combine the states, and then we introduce the epsilon move. I mean, without reading the table, we can have a move. So that is fantastic idea. So we just introduce the epsilon move. So that is called epsilon NFA, and we have also defined with the help of epsilon closure the equivalence of this NFA, epsilon NFA, DFA. All are equivalence. That means if a language accepted by epsilon NFA, then we should have we have constructed a corresponding DFA which can accept this language. So that language is called regular language. If we have a finite automata, if language is a collection of the string of alphabets, set of alphabets, So if so in symbol it is basically sigma star. So it's a subset of sigma star. Any subset of sigma star is called a language. So we call a language is a regular language if there is a finite automata. Doesn't matter whether NFA, epsilon NFA or DFA. If there is a finite automata which can accept that language. So that means language accepted by that finite automata same as this language. And then we have seen that not all language are a regular language. For example, we have seen that language like 0 to the power 1, 0 to the power n, and 1 to the power n over the alphabet 0, 1 binary. This language is not a regular language. Why it is not regular? Because see here we have to count how many zeros we are reading, then how many the same amount of 1 we have to read. So there is no way. I mean our finite automata so far we have discussed has no memory to memorize that how many. So that problem will be solved by. So this is not a regular language, but this is a context-free language. We do have a context-free grammar to accept this language, and also we introduced the pushdown automata recently, and there we have a concept of stack. So in the stack we can store some symbol to maintain this memory, like how many ones we read. So so that was introduced in pushdown automata. So now the question is, then we have after this finite automata, we have defined the context-free language. So there we have some rules on the variables and along with the terminals, and then we define the this derivation of the we define the derivation of the symbols. So like derivation means from start symbol how we can go to the just by maybe left derivation or right derivation, by we just follow the rules, and whenever it will reach to some only terminal symbols. So that is called accepted by that. That string will be accepted by this language. So that is context-free language. So then, so we have defined the parser there. So compiler follows this context-free language we have. So whether it is reaching to a final state, then only the compilation error will be 0. I mean, otherwise it will give a compilation error. So those part we have discussed, and we have seen that 0 to the power 1 and 1 to the 0 to the power n and 1 to the power n having this is a context-free language. So we do have a context-free grammar which can accept this language. So then we introduce the concept of pushdown automata. So there we have seen that we introduced the stack symbol. Stack, another concept, stack. So here our transition function is not only earlier it was a input was a state. Our system is at current state. Our automata is at a current state, and then we are reading the Dept symbol, that is the alphabet, and then we move to the one state or many state depending on whether this is DFM. But here we have another input which is called stack symbol. So here we have a stack, and there are stack symbols. So we just, when we see, we can add something on the stack, or we just pop out from the push pop on the stack. So here there is a concept, two way we can have a acceptance. Either the stack will be empty, so the language, the string accepted by this pushdown automata by the means of empty stack. So if the stack became empty, then we stop. Doesn't matter whether we reach to the final state or not. And another concept is this language accepted by the final state. So if after reading this all the string, whole string, then if we are reaching to a final state and still remain some portion, some symbols will still remain in the stack, we don't care. We'll say the string is accepted by the means of final state, and we have seen this equivalence of these two. So then we have taken example of 0 to the power n, 1 to the power n. So there, whenever a 0 we are making reading. So on the table it is written n zeros, then followed by n ones. So we have start on reading that first zero. Then we put we push a symbol in the stack. That is to memorize that how many. So like this. So every time. So if there are 0 0 like this, so stack symbol. Stack symbol we can use different symbol or same symbol. Usually we use the different symbol. So that way, so we have a stack symbols over here, and then when we start reading one, we will start popping the stack symbol. So if we have stored n stack symbol, if there are n zeros, then we have to pop n one. So that will be at the end of the day, at the end of this input tape, we reach to an empty stack. So that is a language accepted by English stack, which is same as language accepted by the final state. So that what we have discussed. So remaining just 2 lectures, 2 weeks, we will be concentrating on the like pumping them of a pushdown automata. So then we'll be talking about we'll start the Turing machine, so we can move instead of moving the tape can move right here. We are moving sequentially from left to right, but in that case it can come to this part also. So that way. So yeah, so that will be the Turing machine part we'll discuss with the remaining 2 lectures, 11 and 12. So I think if we have any questions, we can. We didn't get any questions on the Google Drive so far. So, but if you have any questions, you can just. So another part is about the exam. So some questions are what is the how to prepare for the exam. So I strongly recommend you to do the assignment by yourself, because as a rule, we have to give some portion of the exam content should be similar to the assignment. Not exactly, it may not be exactly same, but it has to. If you are doing assignment honestly, you should be able to answer this. So that is the thing. And also that as you know, the question will be on MCQ, including this like your assignment. And so, so if you have any questions, anyway, for exam pattern, all these things we can. If we have another session, live session, we can concentrate on that regarding the exam pattern, all these things. So also we have a forum. We are very active on the forum. Thanks to our TAs, that they are working very hard to give your queries, and so forum is very active, very useful. So it's a very interactive thing, so that others can, suppose I have one doubt, so I post in the forum. So advantage is someone might have that same doubt. So so by seeing that, he or she can get the answers. So that is the one of the major advantage of being active in forum. So I always recommend the student to be active in forum. So don't think that it is a silly questions not to ask. Not like that. Anything. I mean, obviously not this subject related questions. You can always ask, and we are always here to help you in that. And then we can just try to give all the answers in the forum. And so if you have any questions, you can just type on the chat, like in YouTube live chat. We will try to address this. So we have another 2 weeks to go. So after that we have an exam. So exam also will be the MCQ. I strongly recommend you to start, take seriously this assignment, all the assignments, and some of the book we are following this so you can just do some of the exercise from the book to get some idea, or to get some to practice. For practice, I strongly recommend you to go through the exercise of the Ullman book. That is very good book to good textbook. Okay, so I don't see any further questions or query or any suggestion. If you have, you can just write on the chat box of YouTube link. Then we can try to address that. Along with me, I have all the TS with me. Mr. Shubhanin Datto, Ms. Surbi Shahu, and then Mr. Ram Prasad. So all are here with me. If you have any questions or any doubt or any suggestion for regarding this course, how to improve this course, or how we can further develop this course. So your suggestion will be most welcome. Okay, seems there is no further questions or suggestions. So anyway, we do have a this forum, so you can always put things in the forum. So once again, thank you very much for attending this live session and for registering this course, Introduction to Automata, Language and Computations. This is a very useful course for to know the subject like compiler, and then we can have a if you want to go for further study on compiler, if you want to do, have your own parser, you can have that. So basically, after knowing the Turing machine, you can get a feel of the initial computer. So that is the yeah. So good evening. So 2 more weeks are to go. So you start preparing for the exam from now, and in the forum also you can post your doubts on this thing. So we'll try to address this. Okay, so let me stop here. If there is no further questions or suggestion from you. Okay, so thank you very much once again for attending this live session, and be safe because this COVID is again increasing. Be safe, stay at home because everything is online now. So try to avoid the gathering. So stay at home, be safe. Thank you very much.